Hey guys, welcome back to part 2 of this Bokeh map series. I want to start off by showing you kind of what we want to get to, or at least an idea. This is just an example on their website, on bokeh.org, pydata.org. They have a ton of different ways that you can graph and make cool charts, and we will be doing something similar. This is just a basic example they have for how to use glyphs to make any type of shape. It could be lines, it could be stars, it could be whatever. And here are just 3 basic points that they plot out, and we want to do something similar but for the streets, and we'll be color coding them based on their relative elevation. So the first thing I wanted to point out is kind of the format that this needs to take. When you're learning something new, at least when I was learning this, I needed to figure out exactly what form my data needed to take, no matter really where it came from. In this case, it's mapsin.com. But the latitudes need to be independent of the longitudes, and you'll notice since this is just for points, there's one for each of these circles up here. So the first points, so the X and the Y, are led in sequentially. So for lines, it's going to be a little bit different. It's going to be a list of, say this was one line right here. It would be these 2 points in its own brackets, and these 2 points in its own brackets, and continued onward, it would be that pattern repeated over and over again. And I wanted just to show you that because that's going to dictate how we derive our points from Mapsin. So this is just something to keep in mind, because when we're manipulating the data, it may not make sense why I'm taking these coordinates, splitting them apart, and eventually I'm going to be averaging these 2 and these 2 together to get an average point for, say this is the line. When making an elevation map, the color between these 2 points is what we want. In this case, we can't draw a color for a point. We need to draw the color for the line. And to get an approximation for this line, we're going to take the average values of these 2 points, and that'll be kind of a pseudo proxy coordinate right in the middle of them, and we'll use that to plug into Google's API, and that whatever color that maps to, once we this is an elevation map. As you go up in elevation, the colors change. Whatever color that maps to will be the color for this line, even though the points are technically the real data points that we have. We'll be using this proxy points right in the middle by averaging them, the 2, and that will be the color that we use to create this. And we'll do that for each line, and together you'll get an elevation map for the entire city. And I'm using Austin because that's where I live. And I'm surprised. It took me a while to realize that when I was first looking at Bokeh, I'm like, why is all their examples about Austin? Then I remembered that this is where they're headquartered. And I actually met the creator of Bokeh and the co-founder of Continuum Analytics. So he's the one that created this. I met him at a meetup one time. I don't think he remembers me. But this is why they have Austin in all their examples. So I thought that was pretty convenient for me, at least. But you can use whatever city is closest to home for you. All right, so like I said, we'll be getting our data from mapsin.com, and we are going to be using the GeoJSON formats. When we import it into our notebook, you'll see that we can manipulate it just as a normal JSON file. There are ways to use this format directly into the map, into Gmap that we were just looking at, but it doesn't exactly form well with how we need to break up the coordinates. So we'll go through that. But Another thing you can do is, if you'll notice that this is the border of Austin. You know, they have extracts for every major city around the world, about 200 of them, I think. But if you get an account with them, you can get a custom extract from them, and that will give you which is what I did. That will give you the detailed borders of each city. So the Austin city limits, and it takes 30 minutes to download, and they'll download it for you and then email it to you. So if you're willing to wait, you can go ahead and do that. But if you just go ahead to mapson.com, and they have I'm not going to go through how to find this page, but it's pretty easy to get to, and you can download this file, and we'll be using that. I already have it. Let's see, right here. And when you get it, yours will be in, it comes in 3 different types: lines, points, and polygons, and you'll have to unzip it when you get it. And we'll just be using the lines graph, or sorry, the lines data points. And let's take a look at how big it is. It's enormous. You can imagine for an entire city how many coordinates line up for the streets. So how many rows are in this? There's, over 50,000 unique line segments. And you'll see, so this is 1 coordinate, 2 coordinates, 3 coordinates, and each of these connect sequentially to create 1 line. And what we'll be doing is breaking these points up into sequential points. So for example, like it'll be 1, 2 will be the first point, and then 1, 2 as a second, 3, 4, and so on. And then we'll be assigning the colors to each one of those segments and plotting them on the graph. All right, so let's get started. I already have a Jupyter notebook started, and here's that Austin line data already there. So let's start a new project, and we will import that using the JSON module. And encode it using the UTF-8 standard as file. And we'll call that dataset lines and load it up. All right. So let's go ahead and take a look at that. Lines, features, and we'll do the first element. So you can see we grabbed that geometry property, and inside there is a coordinates dictionary that holds an array of all these points. And what I was trying to explain earlier is that we'll be splitting these up into latitude 1, latitude 2, longitude 1, longitude 2, and then repeating that where this is the end of this first line segment. This will then be the beginning of the next segment. So this will be longitude 1, or rather latitude 1, latitude 2, and so on. So that's what we're going to do, and the easiest way to visualize it is probably to put it into a Pandas DataFrame. So let's go ahead and start doing that. So we'll import Pandas and initialize an empty DataFrame. And we'll loop through each of these features. So for feature in enumerate lines features. So for feature and features, we'll call these are a set of points, so we'll call them points equals feature. And so the first one is geometry, and then coordinates, and we'll append to that data frame, and we'll feed each of these. So for each of these features, we will append to this data frame using a function that we create. So df append, we'll call that split points, and we'll feed it the points. And let's only do a few of them. So if I equals 10, it's kind of why I did enumerate, we'll break it. Okay, so now we have to create that function. And we'll pass in those points. And we'll initialize an empty data frame. Okay, so for each column, we'll add in, we'll start by labeling them. So the first column will be lat1, and latitudes in this case are actually this second point in the coordinate. So this is the latitude and this is the longitude. So to keep that in mind, so this is the 0th element, this is the first element. So this will be point, actually we're going to do a list comprehension here. So we want points, even though it's a point, point I. So points I is this one if we're doing for I in range of the length of points. And so for I in this range, for the entire set of them, point 0 is this one, and we'll be grabbing the first element, or rather the second element, which is this one, and we actually want the length of points -1, since we don't want to go all the way to the end. You know, once we get to this point, we want to get to this point, we want it to grab point I and point I plus 1, but once we get to this point, we don't want it to go any further since there's nothing after it. So that's why we have length plus 1, or rather -1, and we'll do longitude 1 equals 0.0, and then we'll do the same thing for longitude 2, and this will be I plus 1 and I plus 1. So just again, latitude 1, longitude 1 refer to these two, and then latitude 2, longitude 2 refer to these two. So that's why we have I plus 1 while we're looping through this. All right, and we will return this data frame, and we will run that and run this. And actually, I already noticed a mistake. So if we look at this, let's do df.head, or even better, .tail. You'll notice we only have 28 points in this, and that's, you know, we supposedly cycled through 10 different features, and each of these features has, you know, 100 plus points in them. So the fact that we have only 28 in this data frame shows you that each time we appended it, it overrode itself. So what we need to add here is ignore index equals true. And before we run those changes, let's go ahead and clear this data frame. And we could do that by df.drop. Okay, and if we run this, did not like that. Okay, so now we have these 10 features with all of their points inside this data frame. So that's quite a bit of points for just a test. And now let's go ahead and average those together. So we're going to be averaging the latitude 1 and the latitude 2, the longitude 1 and the longitude 2, each of those together to get this proxy point. And with that proxy point, we can plug into Google's API. So we'll add 2 new columns. So it'll be average lat. And same from the bottom. Okay, now let's just look at our data frame. Not a number. Okay, let's, if we add okay, there it goes. So this is the average of these two, and this is the average of the other two. And now, all right, I think that's enough for this video. We've covered how to import coordinates into our notebook and how to split them up and then average them together. In the next video, we'll take these average coordinates and put them through Google's API and retrieve that elevation for this line segments. All right, thanks for watching. I'll see you in the next tutorial.